Okay, problem number 1. Which expression is equivalent to x plus 3 cubed minus 9x times x plus 3? And there are multiple ways of solving this problem. The first method I'm going to show is if we simplify this, whatever that comes out to once it's simplified, should be one of these expressions. So let's see, we've got x plus 3 cubed minus 9x times x plus 3. Okay, so to simplify this, I'm just going to rewrite x plus 3 cubed as, that just means x plus 3 times x plus 3 times x plus 3 minus 9x times x plus 3. So when you're simplifying, when you have three binomials that you're multiplying by each other like this, or three polynomials that you're multiplying by each other like this, you can only distribute 2 at a time. So I'm first just going to do these two. I'm just going to do these two, and then I'll multiply the product of those by my last binomial. Okay, so x plus 3 times x plus 3. Alright, if I distribute x times x will give me x squared. X times 3 gives me 3x. 3 times x gives me 3x. 3 times 3 gives me 9. And if I combine my like terms, I get x squared plus 6x plus 9. So now that I've combined these two polynomials, let me just bring down my last one that I was saving and multiply each of these terms by this. So let's see, x squared times x will give me x cubed. X squared times 3 gives me 3x squared. 6x times x gives me 6x squared. 6x times 3 gives me 18x. Okay, so the last one then, 9 times x gives me 9x. 9 times 3 gives me 27. Okay, combine all of my like terms. This will be, so x cubed just comes down. 3x squared and 6x squared. Okay, these are both like terms, so I'll just add up my coefficients. This gives me 9x squared. 18x plus 9x. These guys are like terms, so this will give me 18 plus 9 gives me 27x, and then just bring down my 27. Okay, so this whole expression, I'll underline this in blue, was just my x plus 3 cubed. I just simplified this to get me this expression. Now, I will just distribute this other part of the expression. We got minus 9x times x plus 3. So this will just be, okay, minus 9x times x gives me minus 9x squared. Minus 9x times 3 gives me minus 27x. Okay, that's this other part of the expression. Let's just bring this down as well. So I'll have minus 9x squared minus 27x. That was just this part of the expression. This part of the expression right here distributed. Okay, so now that I've got all of my parts distributed, let's just see if there's other like terms we can combine. Okay, so x cubed, there's not anything over there. Plus 9x squared minus 9x squared. 9 minus 9, these ones are just going to cancel each other out because they're like terms, and 9 minus 9 gives me 0, so those cancel out. Okay, 27x minus 27x. 27 minus 27 would be 0, so I would end up with a 0x. These would cancel out, and I'm just left with x cubed plus 27. Okay, that is answer choice A. Okay, so that's one way of solving this problem. Okay, so in the last video, the way we solved it was we used polynomial multiplication and just multiplied, x plus 3, we multiplied that all out, multiplied this all out, and then simplified it, and we got to x cubed plus 27. So we said it was, our answer choice is A. Now let's say you've done all that and you're just a little bit unsure if you did it right or if you got the right answer, or say you weren't quite sure how to do that and you just want to try it a second way. Another way you can do this is just by testing an x value. So in this case, I said pretend x equals 3. I could have said pretend x equals 4, x equals 5, any value. I'm just going to choose some value here and plug that in for all of the places where I have an x. So in this case, when I've got x plus 3 cubed minus 9x times x plus 3, instead of saying x, I just put in 3's where all of those were. And if we calculate this out, we would get, okay, let me just plug this in. So I'll have 3 plus 3 cubed minus 9 times 3. Whoop. Let's be careful not to do that. So it's just to the 3 over then. Minus 9 times 3 times 3 plus 3. Okay, so if I enter all this in, I get 54. So in other words, for our answer choices A, B, C, and D, if I plug 3 in for all of the x's, I should get out an output of 54. So whatever your output is for A, B, C, and D, the one that's equivalent is the one that's going to have the same output when you plug in some input. So if I plug in 3, I should get an output of 54. If I had to plug in some other number, I should get the same output as whatever I have for our expression that we're testing. Okay, this open expression that we're testing. So let's see what I get for A. So if I plug in, okay, 3 cubed plus 27. Whoop, I keep making that mistake. 3 cubed plus 27. That gives me 54. So this one right now, I'm just going to put a check next to it because I know this one worked. I'm not going to stop right here because if something else also gives me the same answer, that means I'll need to pick a new number and keep testing it until I get only one that works every single time. So let's try it for B. So if we go, all right, 3 cubed minus 27, this gives me an output of 0, and that's different from my test value, from the value that I have in my that I'm looking for equivalence to it. So I'm going to cancel B out. That one does not work. Let's try it for C. So if I have, okay, 3 cubed minus 9. Okay, 3 cubed minus 9 times 3 squared minus 27 times 3 plus 27. This gives me an output of negative 108. Okay, so this one gave me 0, so I crossed it out. This gave me negative 108. So that's not the same as 54, so I'm going to cancel that out. Okay, for D, let's plug in 3 for each of these as well. 3 cubed minus 9 times 3 squared plus 20 squared plus 27 times 3 plus 27. This gives me an output of 54. Okay, so right now I've crossed out B and C, and I know it's down to either A or D. It's one of these two. So if you get it where you've got two answers that both give you correct outputs, just choose a different number. Just choose a new number now. So instead of saying x equals 3, let's test out x equals 2. Okay, and the one that's going to be correct is going to be the one that still gives out the same output. Okay, so I'm just changing all my x's to 2's now. Okay, and so I'm just going to, B and C I know are wrong for good now. So let's just see in my original test app, let's see what our output is when x equals 2. So if I have 2 plus 3 cubed minus 9 times 2 times 2 plus 3. Okay, this is going to give me an output of 35. So now I'm looking for which of my possible answer choices has an output of 35. Okay, so 2 cubed plus 27 gives me 35. So right now I still have, this one is still a check. This one's still good. So this one is still giving me the same thing. So that means that's another little test that it is an equivalent expression to that one, because we've got now two different numbers that it gives us the same value for. Okay, then let's do the second one. So 2 raised to the third minus 9 times 2 raised to the second plus 27 times 2 plus 27. This gives us an output of 53. This is different from 35, from the value we're looking for, so therefore we can cross out D, and we're left just with A. So here we had two different methods. I'll give you two different methods for solving for this one. The first one was a deductive method, where you were just simplifying out the expression and then seeing which one ended up having being the same way that it was written here. Okay, we just simplified out the expression. We just followed our rules of math to get our solution by deductive reasoning. Or you could just test out different values for x. This is an inductive method where we did different tests to see which one maintained equivalency when we were plugged in numbers. So either method works. Maybe do both of them so you can be really sure about your answer. But there you go.